All right, 5.4, modeling and optimization. Apparently, this is one of the sections that my notes must have deleted part of last year, because the first like 3 examples aren't in my packet from last year, but that's what I just went and printed because they just look nicer than my other ones, so I thought it'd be easier to use those, but I'll have to wait till I get to those ones to actually use them. All right, so like I said, there really aren't notes for this, but just kind of a strategy for min and max problems. And we've done these before briefly.
Strategies.
Huh?
Love strategies.
So we've done these kind of before, but not using calculus. When we would like use our calculator, we would like graph the function that like made up whatever our thing was, and then we would use the calculator to find the min and the max for like the like optimizing like the size of the shoebox, I think was one that we had, and stuff like that. But we'll be using calculus to do it now. So the first thing is to just understand the problem, which obviously that's kind of common sense. We have to be able to understand the problem before we get too far. And then we need to develop a mathematical model of the problem. Three, we need to graph the function. Which, again, typically is going to be on your calculator. 4, identify the critical points and endpoints. So, obviously, like, with that comes, you know, to an extent, sometimes they have to tell you certain information about, like, endpoints. But then there's other things like I can't have like a negative distance and things like that, or negative time and all. So if we're maximizing or minimizing, you know, like the area in a box or whatever, or I guess I should say the volume in the box, area doesn't make sense, then I obviously can't have like 0 volume for an actual box. Like if I have 0 volume, then there's no box.
It's just like a piece of cardboard or something.
Yeah. So pretty much just like it has to like logically make sense, right? When we're choosing these numbers or identifying them. 5, solve the mathematical model. And then 6, interpret the solution. And that's not necessarily like in stats when we say like draw a conclusion, interpret the solution or whatever. Obviously, there's usually like a lot to that. With these, it's kind of just like the max volume is when the length, width, and height is blah, 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 blah. Like it's not like anything crazy.
It's not like a whole paragraph.
No. You're just, it's, to a point, it's almost just like mentally thinking about it. Now, if they actually ask you on like the exam, interpret what this means, yes, you may want to write out and not just keep it in your brain, but you're kind of just analyzing it as far as that goes. So, and I would say that there is a possibility that a problem like this could be one of your short answer questions. I obviously don't know that for sure. They don't tell us, unlike they do in pre-cal. But I would say that there is a chance that something like this could be one that you would have, because this kind of applies what we've done so far in the chapter. So, anyways. All right. Gosh, having a Band-Aid on the finger that I'm like attempting to do stuff with is super annoying. Had a fight with a chopper and lost.
Sounds horrible. This looks like from like Final Destination.
It did hurt. Yeah. My index finger is pretty much better, but my thumb's not.
Yeah, there.
And it was like doing onions too, so I was already like crying from the onions, and then on top of that, adding
so it's
that
like
in.
You're actually crying. now.
Yeah, it was like,
Too much.
yeah,
So was that all of the notes?
yes.
Okay, I was wondering why there was a number 2.
Yes.
Underneath the 6. I was also wondering why it wasn't in line.
Is that bothering you?
No, I thought it was like supposed to be a
For
second
Josh,
one.
end of notes.
But like, I was wondering why there wasn't the 1 at the top. Like, I don't know, like what? Maybe this is the
1.
no, not like that. A 1, like right underneath.
There was a
strategy
1.
for min and max
Yeah,
problems.
there is a 1, Josh.
No, like another 1, like strategy 1, you know, and then we have strategy 2. That's what my brain is thinking.
Oh.
It's like, wait, why didn't she call it number 1?
All right, number 2. What is the largest possible area
Answer is Virginia.
for a right triangle whose hypotenuse is 5 centimeters long, and what are its dimensions? So this section, obviously, as you can tell, is going to be a lot of word problems, which are always the fave. So I would start out by pretty much straight up just drawing a picture. Like, first thing if you can. That's not really one of the steps that's given, but honestly, usually pretty helpful.
I mean, I think it falls under the understand the problem.
I mean, yeah. So, like, it was funny. So, when Mr. Cass taught, he wanted, like, a picture drawn for, like, absolutely everything. Like, every physics problem had a picture drawn with it and whatever, which is fine.
I'm not an artist.
Sometimes I don't think we need a picture for everything, but, like, there are things that it is helpful to see a visual. Anyways, so when the kids graduated, they would always be like, thank you, Mr. Cass, for teaching me that I need to draw a picture to represent all of my math problems. It was always funny. All right, so right triangle, hypotenuse is 5 centimeters. I'm going to say I don't know what the dimensions of the other two sides are, so I'm going to call them X and Y. So what is the formula for area of a triangle?
Half the base times the height.
Yep, so I'm going to do half of X times Y. So area equals 1/2 XY. What other formula do I associate with right triangles typically? So x squared plus y squared equals 5 squared, or I'm going to write it as 25. Oh, this stupid thing. I turned you off. What are you doing?
Mine always does it too when I'm writing. It's like, because I write it in angle. So it's like saying that it's not lined up, where I'm like, I don't care. It's just annoying.
Virginia writes in theta.
Yeah.
All right, so I'm going to, in this equation, get y by itself. Doesn't matter if I choose x or y. I'm just choosing y because that's what I feel like.
I would choose y.
So y equals the square root of 25 minus x squared. And then what I'm going to do is I'm going to take this and plug it in here. So I will have a equals 1/2 times x times the square root of 25 minus x squared. Now, it might end up being helpful because of what we're about to do to rewrite this as 1/2 x times 25 minus x squared to the 1/2. There could be some benefit there. So these problems are just asking us to do this analytically. So at this point, I'm not graphing. But typically we would graph here and start to look. But what I'm going to do is I'm going to take the derivative of this function.
So that's the benefit.
So dA dx to the derivative of area with respect to x. Now, you obviously can still write a prime if you want to. That's fine. But I've obviously got a derivative here that I need to deal with. So what rule do I have?
Product and chain.
Yep, product rule and a chain rule. So what would the derivative of this be?
Let me think about that.
Here, y'all do it on your papers and then we'll compare.
Alrighty.
And go ahead and like simplify it down as much as possible. Let me know when you have it simplified. This might take us more than my anticipated 2 days.
Maybe.
Well, in fairness, I didn't think we had as many examples as we do because I just was looking at my notes online and not my other notes. So, do we have our derivative yet?
Not simplified.
I don't know how this. I might be erasing a lot after this.
I'm having, I guess I could call it parenthetical trouble. That makes sense.
All right. Well, let's just go over it then.
Okay.
Because I feel like we should be through this by now. Josh is giving me the I have no idea what you did look. Or I guess he's giving it to the screen, but
So the 1/2 x and the negative 2x are they just become negative x.
yes, but I also had this.
Right, but those two just become negative x,
Yes.
not negative x squared.
No, it is squared.
Oh, okay. I mean, I didn't. Do
Quite
this.
honestly, when I was doing it, I think I crossed the X out in my head, and that's why I just did.
So, if I was just writing the negative x squared in like parentheses, where would the negative go? So it would go.
It just goes in front of everything, because that whole thing, all this is being multiplied.
So it's like negative x squared, not negative x
Yes.
squared. Okay. So either way, it's negative. Right?
Yes.
Cool. Love that. Not really.
But at this point, we need to find critical points. So I need to set this equal to 0. Any ideas how I need to go about solving this, considering I need x by itself?
Alrighty, so I'll just say that 0 is a 0. Not sure how to go about solving it yet, but
That's not the case, because these are also lengths, so...
oh yeah.
Alright, so let's do this.
Is 0 for the
This
second
is
part, so-
minus all of this, so let's add this to the other side so that I end up with the square root of 25 minus x squared over 2 is equal to x squared over 2 times the square root of 25 minus x squared. Any ideas now?
Multiply by like denominator of right side. Cause canceling.
Oh, you want me to multiply by this whole thing? Yes?
Yes.
Is that what you're trying to get me to do?
Yes.
Okay. Yes, so I'm going to do this. Multiply, I don't normally do this at this point in your careers, but I feel like we're going to lose something if I don't do this, so. And it's gone from
I would
this
do
side.
that. I would do that.
Alright, so these 2's canceled, and the square roots cancel, right? If we have a square root of 3 times the square root of 3, that's just equal to 3. So this is just going to be 25 minus x squared equals x squared. So 25 equals 2x squared. So 25 over 2 equals x squared.
Yeah.
Now, obviously, I can't have a negative number, so I don't really need to do the plus or minus because I can't have a negative side length, so I'm not worried about that. Just don't forget that square roots are always plus or minus. That's just not possible for this one. So this is going to be 5 over the square root of 2, or 5 root 2 over 2 is x. Now I need to find y. So I'm going to circle this so I don't lose it. So y is equal to the square root of 25 minus 5. Actually, here, I'm going to do it this way. I'm going to use the 5 over the root 2 squared just to make life easier. So this is going to be, look, I'm going to do this. 25 over 2 over here And then this initial 25 is going to be 50 over 2, so I have the common denominator. So this is the square root of 25 over 2, or 5 root 2 over 2. So they happen to be the same,
Who would have guessed?
which kind of makes sense. So here's the other one. So the dimensions are 5 root 2 over 2 centimeters by 5 root 2 over 2. I guess I shouldn't do by. I guess I should do, well, I guess that's fine.
What? Should we just say
I'm
what
just
the
gonna
length
say-
and width and whatnot are?
Well, yeah, but these are side lengths of a triangle.
Yeah.
That's why I also feel weird saying by, because typically that implies it's a square. The book says by, but I think that's weird. So I'm just going to say x equals blah, blah, blah centimeters, y equals blah, blah, blah centimeters. Now I need to find the area to get the largest possible area. So area equals 1/2 times 5 root 2 over 2 times 5 root 2 over 2. So this is 25 times 2 over 8, or 25 over 4, which is 6.25. I feel like I should say centimeters, because the book doesn't even put units on it, but I feel like that's just not right.
I just wrote centimeters cubed.
That would be volume. So the answer to this problem is everything I have written in green here. And that's just one problem.
Wait, so, oh, okay. I was,
Now, I'm going to tell you, they don't all take that long. Some of them are faster than that, but
I didn't realize you would put the area in the green too. So I was like, wait, so we solved for the area for nothing?
no, I just figured I'd go back up and throw it in there together. All right, let's see if we get another one in here before. I feel like this class was like insanely short.
Yeah, I don't know why.
I don't know. Weird.
Maybe it's because we actually like each other.
We didn't even really talk that long beforehand.
I know, that's what I was saying. Like,
I mean, today we actually didn't talk that long.
Yeah.
So
I don't know. Show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square.
I knew you were gonna say square. I mean, it makes sense that the side lengths would be equal.
With the 8, what is that, meter?
Meter, yeah.
When you think about it, like perfect squares. You know, take like 3 times 3. You know.
All right, so what do we know? What formulas do we know in regards to a rectangle?
Length times width is area, and then 2 times length was 2 times width is perimeter.
Yep. So, and I know that, or it says show that among all rectangles with an 8-meter perimeter. So I'm going to rewrite this as 8 equals, and I'm actually going to factor out the 2. So I have 2 times L plus W like this. Then divide by 2. So 4 equals L plus W like that. Now, I need to solve for one of the variables to plug into the other one like we did up here where we solved for, we got y by itself. Let's just do w. So w equals 4 minus L. So I'm going to now replace this 4 minus L in the W formula up here. So A equals L times 4 minus L. So then A equals 4L minus L squared. Now I need to find the derivative. So I'm just going to write it as A prime this time. What's the derivative of this?
You got this, Virginia.
Hopefully this is easier than the last one.
4 minus 2L.
Yep. And we set it equal to 0 to get these critical points. So L equals 2. Now, if we wanted to, I didn't really do this on the last problem, we could have, but the one with the largest area is a square. That means that it has to be a what?
Perfect. Meatball.
Max.
Max. I didn't even know what the question was. I was just trying
The
to-
largest area implies that it has to be a max.
I didn't understand it. I thought she was just going at us. Just to say
So I could check the sign of the derivative. If I put in 1 to the derivative, is it positive or negative? Y'all are scaring me. If I put in 3, what is it? Negative. So it goes positive to negative. So that means it's a
I wasn't looking at the
Max.
derivative.
max. Okay, so I know for sure then that this is a max.
I wasn't looking at the derivative.
I could tell. So now I need to solve for W. So W equals 4 minus 2. So W equals 2. So I've got my dimensions here. I guess I should put meters on here since they did tell me meters. Then it wants, or we can confirm or whatever what the area is of that. So, which it already makes sense this is a square because the length and the width are the same thing. So area equals L times W, which is 2 times 2, which is 4 meters squared. So again, I've just shown that that is, in fact, the truth.
No lie detected.
All right, so tomorrow, I always hate that one problem. I don't know if we'll do it or not. We'll see how I feel about it. So it might take a little bit of Wednesday, too. We'll see. I don't think, honestly, the first one always takes a little longer. After that, they're a little easier.
Well, like number 2.
Yeah, I don't know why that particular problem tends to take a while, but we'll be doing
Scary derivative.
one that involves, I think it's like, it's either a box with a lid or it's like a suitcase. We'll do one that's like a cost, like a max cost or something like that. One with a fence. That's like a fenced-in area, I think.
So offensive.
Yeah. One that's like a velocity kind of thing. Anyways, but there's one that's a rectangle inscribed in a parabola.
Joy.
And that's the problem. I really don't like that much, so we'll see.
Or will we?
I may come back to that at the end and actually get into some of the word problems. And I won't necessarily write out all the word problems. Like, I might just write out critical information. Because it's just not that big of a deal, so.